How to add notebook? I don't want to add account. Okay, here. So what I have studied in this chemistry is there is first of all is this okay? Yeah, this is much better. So first of all we have what the heck? Uh, we have pure and impure sub mixture. Pure is like atom, and like atom in sense of like an atom of like supposedly like hydrogen or helium or lithium or beryllium, boron, carbon. Impure is like mixture is like of homogeneous or heterogeneous. So if you don't know how to differentiate this, how do you look like crazy here? If you don't know how to differentiate the homogeneous or heterogeneous, just remember that homo always mean wait, homo always mean same, and hetero mean different. Hetero. So like homogeneous mixture are like your of same like viscosity or which can be like mixed together. Like if you want to say like water plus salt, like H2O plus NaCl, or if you want to talk about like what water plus sugar. Heterogeneous, you could remember it like as of like how you can't mix water plus oil. That is basically that. And mixture, this is also an CDS PYQ. There were like options like sugar. There was an option like sugar. So sugar is a mixture because it is made up of like sweet corn, sorry, sugarcane juice and like crystallizing it and so adding some chemical. So yeah. Uh, so now we have Dalton atomic theory. This theory says that invisible no matter tiny particles. So like uh, general idea about like as of like atom, like like this, then wait, what the heck? Why do you copy it? What is what happening? This, yeah. So let's take an example of as of like hydrogen. So this is the core, okay? So the core have your proton plus neutron. Can't I zoom it more? Okay, I drawn it too little. Okay, so proton and neutron. So the first of all in an atom, proton makes about 99% of the weight. Then comes your neutron, but we call them neutron as the weight like the weight guy, you could say, like they add the weight. We say that because like proton is everywhere, right? Proton is like on your every atom, and they are different number, but the main difference is making is the neutron. That's why I'm guessing it. I don't really know that much theory. I didn't really pay attention because like the theory changes ahead. So okay, that atomic theory. The flip is happening, brother. So the thing that helped me in learning this earlier, I was not good at chemistry. I think I'm still not, but I tried a little. So the thing that helped me was knowing your cation and anion. So like supposedly if you're talking about like if you want to talk about oxygen, then fluorine, atomic number 9. This is an anion, as this fluorine its shell valency is 2 is the minimum here, then 6, then you could say 268, and 26, you could say 27, sorry, 27, wait, 2 and 7. So 2 7 is the fluorine valency. So now to reason to call this anion is because like when you're talking about fluorine, it is so the main thing is that every atom in the orbital, at the first orbit everybody want to make two electrons should be like at the first orbit, like here and here. At the second one everybody want to be become an aucklet, and in the third one they can be aucklet, but there is like 18, they are 18, and the next one is 32, and it goes ahead like that. And so like if I tell you that the Like the fluorine have like if we talk about its atomic number 9. So the proton, first of all, they tells what would be the element on basis of their atomic number. So if a proton number is like 9, then it would be a fluorine. If it is 8, then it would be an oxygen. So proton is the, like, if you change the number of proton, then you're changing the atom basically. So in a fluorine which is 9, there is 9 proton which are positive and 9 electron which are negative, right? So so its valency is 2 and 7. Now he want to become an aucklet, so he would like to have plus 1 electron which is negative, right? While this is the case when fluorine, supposedly there is a hydrogen there. So when fluorine bonds with hydrogen, hydrogen becomes cation, and hydrogen have a thing that he can become cation and anion. So here he become cation and gives it to fluorine. Okay, so when it gives to the fluorine, then basically what I'm trying to say, there would be like 9 proton was there, right, at the start. Now there would be 10 electron, and the whole thing would become your anion, which I told you is negative. It's negative in sense of the whole thing become negative, and the electron number increase. Okay, and cations are like your cations. So anions are basically your nonmetals, like as I told you, fluorine, oxygen, nitrogen. Those are your nonmetals, and cations are metal like sodium, potassium, uh, calcium, magnesium, aluminum, your iron. Sorry, Fe. Yeah, I think iron is 80. It is like 2, 18, 32. So like what is this? Uh, 0, 4, 5. No, it is like 2, 18, 18, 36 plus 32, 8, 6, then 7, 70. Iron valency is 70. Twenty-six. I'm talking about that. Okay, so like 2, 8, 10, then 16. Or you could say like 2, 8, 8, or 8. 2, 8, 10, then 26, so 16. Then 2 more. Rutherford, like one got removed or something. Uh, then proton and all that. Then electron, atom number 2, 8, KLM. What's the formula for this? Yeah, 2n square. So 1 is 2, 2 is 8, 4 into 2, and then 3 is what? 18. 3 square, so 9. No, 2 n square, right? So I'm talking about 3. 2, 9, 18. And hydrogen symbol is this. This Mercedes is also somewhere. Phosphorus. Then sulfur is hospital. Then this is mercury. Yeah, mercury. Yeah. So now talk about, as of like, you should know till 20 uh, of these. But like, what was this halogen like 13th, sorry, 17th group, as of like your fluorine, 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 uh, your then chlorine, see, as chloro, then 35 as fluorochloro. What was 35? Chlorine, bromine as bromo, bromo. Then as 53 as iodine, as iodo. So like if it is like carbon, this is like, here it is like Cl, or here is like this, so it will go 1 2 3 4. Now methane, ethane, propane, butane, not, first of all, not butane, it would be like 2 chloro, 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 2 chloro, 2 chloro, butene, ene. We don't write ene. I don't know. I don't get that. But like when we talk about alkene, we write it like that. While we write alkane like this, and while we write it like this, whenever if this thing was not a double bond, then we would have written it like 2 chloro uh, butane. We writing ane. Whereas we don't write here. We write en. I don't get that. Okay, so hydrogen, helium, lithium. Helium is a gas, octane gas, noble gas. Fourth is your beryllium. Fifth is your hydrogen, helium, lithium, beryllium, boron. Sixth is your carbon. Seventh is your nitrogen. Yes, 2 and 4, 5, 6, 5, 6, 7, 5, 2 and 5. Then 8 is your oxygen, 2,6. Then ninth is your fluorine. As of like the most, uh, what was that? Most like negative. It was somewhere negative. 2 and 7, like HF or FS, FH. 10th is your noble gas neon. 11th is sodium, 281 cation metal. 12th is your magnesium, Mg282. 13th is your magnesium, it's your chlorine, I think so. Magnesium, then aluminum, then uranium, silicon, 5th phosphorus, 16th silicon, phosphorus, chlorine, Cl. No, no, silicon, phosphorus, sulfur, chlorine, पोटैश नहीं क्लोरीन, क्लोरीन के बाद क्या भाई, क्लोरीन के बाद क्लोरीन आर्गन, हाइड्रोजन, लिथियम, बोरोन, बेरिलियम, बोरोन, कार्बन, नाइट्रोजन, ऑक्सीजन, फ्लोरीन, नाइट्रोजन, नाइट्रोजन, ऑक्सीजन, फ्लोरीन, नियॉन, sodium, magnesium, aluminium, then your aluminium, sulfur, phosphorus, silicon, sulfur, aluminium, okay, silicon, phosphorus, sulfur. Okay, so uh, okay, so neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, sulfur as 16, sulfur, then chlorine, then argon, then potassium, then calcium. Yeah, hydrogen, if it is like, no, if it is like 1, this is protium, deuterium, then 3 is your 1 your need, uh, deuterium, then tritium. Then there is a pretty annoying thing that I studied, which was SPDF. Is that right? Yes, that is right. S is like 2, P is like your 6, D is your 10, F is your 14, I think so. So on this you have to like different, right, like oxygen, then you will the oxygen fit perfectly as 2, as you would like, as like 1 as 1 as square, then uh s s is done, then 1s square, 2s square, then 2p4, this shit. Then there was a differentiating thing here in iron and your chromium, iron being your 26, chromium being your CR, Cristiano Ronaldo 24. Chromium and iron, as of like if you go to differentiate it, first of all write it like this: 2, 8, 14. Now it goes 1 and 13, I think so. Yeah, so like sorry, 1s square comma 2s square comma 2s square comma 2p square comma, sorry, 6 square, sorry, 6, sorry, 6 power 6, so 2, 8, this is done 10. Now 3s square 12, then 3p square, sorry, 6, so 10, 8, then comes 4s1, then so this is 18, 18, 19. So I'm left with 7, so it would be like 1s square, and then comes like third have spd, so 3d, what is this, 6 is there, 26, so 1 7 3d7. This is for iron, and for chromium it is like 1s square comma 2s square comma 2p6 comma uh, 3s square. So this is 10 done. 3s square comma 3s6, 8 done. Now I am left with 24, 18, and here it does a weird thing with 4p1. So 18, 19, I'm left with 5, so it goes to like 3d5. So basically SPDF 1 2 3 4, and the first orbit has S, second orbit have SP, third orbit have SPD, fourth orbit have SPDF, fifth same, sixth goes to SPD, then goes down till like 6, 7, 8. 8 is the last. Copper and iron. Copper and iron basically learn like copper Cu and iron Fe is these both have 4p, so 4s1. They're pretty annoying to study actually. Wait a sec. Okay. So N, and this goes to L. L goes to 1, 2, 3. No, no. L. Then L goes to 2. Then this 2 goes to M, and this M does that. Okay. So if they ask about this whole thing is quantum number. So like if you talk about QUNTAM quantum number, and specifically if they ask like if this kind of value possible, so first of all it is like number, how many number are there, like supposedly 5 is there. So now you have to do n minus 1 on this to go to this is quantum number. Now your L is your angular momentum. Now quantum number to angular momentum formula is n minus 1. So if it is 5 quantum number, so angular momentum would be 4. Now if you have 4 angular momentum, then your magnetic quantum number would be there m. So L, then n minus 1 to sorry n minus 1 to L to m, L. ml, the magnetic quantum number ml would be represented. If there are four, then you will go from -4 till -1, write 0 here, till 1 till 4. So 1 to 4 is 4, this is 4, this is 1, so 4 for 4 is 8, 8 1 is 9. So 9 are your possible outcome here. Out of this, there is a question like, if there is like n3 comma l2 comma m is equals to -2, if this is possible, then you will say yes, because like n minus 1 is 2, then 2 have a possible value of -2. Basic quantum number, angular moment, and magnetic. And the spin is like you're going here, so it is like +1 to -1. Yeah. So now is your alpha, beta, and gamma rays. So like you have read alpha, beta, gamma. So these are came from here only in chemistry. So alpha rays are like alpha in sense, and like if you have like argon, atomic value 18. Now alpha rays are basically helium. Helium has a atomic number 2. Now helium gives to this guy, and this thing becomes like 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 what I want to say, that alpha ray alpha ray helium is there, it is giving to argon. Now argon would change to your calcium. So alpha ray have the ability to change and proton number. In sense of proton number, you are changing the basic element too. So that's alpha ray, and these have very high uh, ionic power and very low, I would say low penetration power. Now there is beta ray. These rays consist of negative charge electron and have -1 until charge and have zero mass. Increase the proton by 1. No neutron mass. Neutron mass remains same. So like alpha, beta ray is also there. Beta ray is like it increasing by one. So yeah, and like this does to a negative electron. So one negative electron would be like your, if I had to say fluorine 27. I guess that's why fluorine is the main example here. Then it is your alpha, beta, gamma. Gamma have like high penetration power, I think so. Penetration power, yeah, very high penetration power, and very low ionic power. And so like the ionic power is the one. So like if this type of question comes like rank alpha, beta and gamma on basis of ionic power. So alpha, you know how it is changing the number of like a proton, then making it bigger. Same with beta with 1, and alpha is not doing anything. So this is the basic order. Alpha is the most ionic power, beta is in the middle. Ionic power is also good, but penetrating power not good. But alpha penetrating power is very poor. Then beta ionic power is very poor, but penetrating power is very high. Nuclear fission, yeah, nuclear fission is very easy. Nuclear fission, yeah, this is also thing. Fission and fusion is two different things. Fission is like there is an atom, you are breaking it. Fusion is like you are putting four atom one place and releasing a high level of energy. And for fission, it is atomic power uranium of 235 of 92. What is yeah, uranium is 92. Uh, 235, 92, and 239 plutonic 94. Plutonium, uranium. Uranium 92 to 35, plutonic 94 to 38. And like the nuclear fission, the main energy source of sun, and through which we have sunlight and we are living and we are able to live, as happens because of hydrogen comes there, which all have one valency, comes to your hydrogen, helium, lithium, beryllium. So they comes to your helium, and you would say like helium is like 2, but this one is like 4 2. So after 4 combine, this becomes the this, and h power, so the 10 power, what was the temperature, 6 Kelvin. So like 1 2 3 4 5 6, this is what, 1 crore Kelvin. And there is no cold. The lowest you could go to 73 degree Celsius. This is absolute zero in a sense. Cold doesn't cold is not a thing. It is just absence of heat. If heat can be as much it can be. Then there is radioactive, like iodine is 53 of 131. This one helps in goiter. And iodine of 123 of 53, 120, 131 and 123, and uranium of 235 and plutonic of 238, and iodine of your this is 53, this is 131, iodine of 123. This is on goiter, this is on brain picturing. because like these are radioactive, and they, whenever they get absorbed, they send, wherever it got absorbed, it sent radioactive way. This gets absorbed in goiter here, and this goes into your brain. Then there is sodium, then there is phosphorus, sodium 24, phosphorus 32, sodium Na 24 11, and phosphorus 1532. And these are for leukemia therapy and नमक खा के absorb हो गया है. Helping blood flow. Oh, so blood flow helping is 24, because like the sugar get, so not sugar, sorry, salt get absorbed in like the blood easily, I would say. Then there's ionic bond, these bond. I would say this is pretty easy. Then there is organic chemistry. I will do it tomorrow. Organic chemistry, it is easy. Like it is like just like this: methane, methane, ethane, methane, ethane, propane, butane, uh, pentane, hexane, uh, heptane, then octane, then nanonane, then deconane. Don't really need to go ahead of this. They would not ask much more than this. Then there is your alkene. These are the, what is that word for that? Hydrogen something. Saturated hydrocarbon. Alkene are saturated hydrocarbon. Where did I wrote that? What? No, I'm talking about. There it is. Homogeneous series is alkene, then isomer. Ah, okay. So alkane is there, which formula is like CnH2n plus 2, then alkane, then alkene is there, which is like double bond in a carbon, and this formula is CnH2 and 2 got reduced here because double bond takes only two hydrogen. Then there is your alkene, which is like triple bond here, like it is CnH2 and minus 2, because like they are double bond. So like two hydrogen is lost, so four hydrogen is lost in alkene. Yeah, so that's the thing. Then there is naming process, like if I had to go like this, this, then this, then this, then this, then if I had to go like this, then this thing would be named as, first you write C A B, B comes first, right? So you will write, first of all you name them. So 1 2 3, wait, let me write it closer. Did I miss something? Why is this thing so light? What a dark color. Bromon, okay. Bromo. So 1, 2, 3, 4, 5, 6. We start from 1 because it is double bond. If there was no double bond, then we have would have start from 1, 2, 3, 4, 1, 2, 3, from the right to left. So this would call as 5 bo BROMO, 5 bromo, 5 chloro, chloro, 5 bromo, 5 chloro. Then you call it uh 3 dimethyl, 3 dimethyl. Then you called it one. How many are there? Six. So pent. No, so hex. Sorry, hex. Pent is 5. Hex is 6. So hex. So heptagon. So hept. Then you will write it as hept. Then you will write as 1 en. Then write as 3 yne. I guess this is how you write it. And this is organic chemistry, I'm guessing. It was pretty easy. I did it in like 3 hours. I guess people might have taken it like a little more. Not the whole thing, but like most of the organic chemistry, I'm guessing. People might have taken a less than that. So I guess thanks for watching. And continuing this, I will continue this from like the chemical series and like isotopes, isobar, and all.